Okay, another little problem with my definition of written here. Um, I say a set, right? So I should be using a brace around my vectors there. And now that that is a set, this symbol here is no longer appropriate. We should be using a symbol like this. And in English, this is a subset of. So in English, we're saying this set of M vectors is a subset of Rn. Said a different way, you could say this set is contained inside of Rn. Okay, little details. Let's do some examples of independence and dependence. Okay. Independent or dependent? Question mark. And then we'll say we want to justify our answers. So I'll give you a set. 2, 1, 0, 1. B. One, -2, -2, 4. And C, something in R3. 1, 2, 3, 4, 5, 6. 2, 1, 0. So independent or dependent. A. So what does it mean to be dependent? It means that I can find a non-trivial dependence relation. Like this. So I'm going to go try to find one and see what happens. So I'll write down A1 times the first vector plus A2 times the second vector, and that's equal to the 0 vector. Okay, what I've done here is just copied this equation where we have 2 vectors and just A1 and A2. Okay, so I'm going to try to find a dependence relation. Well, what happens? Well, you end up doing something familiar. You end up with 2A1 and then A1 plus A2 is equals 0. This equals 0. So you get a matrix, right? 2, 0, 1, 1, 0, 0. So I'm trying to find a dependence relation. So I'm trying to find what are the possibilities for A1 and A2. I end up row reducing this matrix. And what happens? You get this by dividing the top row by 2, and then one more step gives you this, and therefore A1 is equal to 0, and A2 is equal to 0. So the conclusion here is that if you're looking for a dependence relation, only the trivial dependence relation works. And what does that mean? Well, looking at my definition, that's independence. So only the trivial dependence relation, we'll say, exists. Therefore, the set is independent. This is the definition. B. A1, 1, negative 2, plus A2, negative 2, 4, equals 0, 0. Okay, I'm going to go about this the same way I did part A. Use a matrix, negative 2, 4, 0, 0, reduce, and what do you get? Well, you get a free variable. So very different than part A. Okay, well, this tells us that therefore there exist non-trivial dependence relations. Therefore, the set is dependent. Okay, this free variable here, what it says is A1 minus A2 is equal to 0. No, A1 minus 2. A2 is 0. A2 is free. So I have an infinity of solutions here. I could take this solution, for example, A1 is equal to 2, A2 is equal to 1. I can see up here, that gives me a non-trivial dependence relation. In fact, you have an infinity of them. You do have the trivial one. Okay, you do have the trivial one where you have 0 and 0. Okay, that is one of the solutions here. But the point is that you have more that are non-trivial. C.